this is an easy lesson for you. It should be review. We're going to dig into the stuff about logs that you really better make sure you know. Properties. The first thing we're going to remember is expanding and condensing logs. Do you remember how to do that?
It's fine. It's not hard.
No, it's not hard. You did so bad on this. Here's what I want you to do. I want you to get on your calculator, blank screen. Calculator, blank screen. I want you to go to math, far left. Start arrowing down. Now, option A. Option A. Click on option A. Now, if, I know she does, yep. Now, there may be a few of my calculators that have that disabled, but some are good. Okay, just watch Eve's when we're working on this. This is not a key that you're going to be using on homework or quizzes or tests, but you can use it on the ACT. However, this is just some stuff I want you to see. The calculator that you have, is it disabled? Is yours? No. Then he can just watch yours, okay? Now, what I would like for you to do, if that command is not disabled, I would like for you to type in this. Okay, so I'm hearing a few people say you're getting 3 for this answer. Now, how is that? Because this says right here, 4 to what power equals 2, right? And this one says 4 to what power equals 32. Now, we could do some stuff with that. Could we do some stuff with that? I want to show you something. This is just like a problem we just did from your homework. Can I rewrite 4 as 2 to a power? What is it? So, 2 to the second power, right? So the question here is 4 to what power is 2? No, I don't want to do it like that. 4 to what power is 2? 1/2, right? Because the square root of 4 is 2. So do you agree that that's 1/2? So the answer to this piece right here is 1/2. Now, 4 to what power is 32? So here's what I'm going to do. I'm going to write 4 to the x equals 32, and we're going to figure out what x is. 4 is 2 squared, right? So 2 squared to the x. When I raise a power to a power, what do I do to the powers? So that's 2 to the 2x, but this is 2 to the 5th. So if 2 to the 2x equals 2 to the 5th, then we know that, right? So what's x equal? 5/2. So what we've got here is 1/2 plus 5/2, which is 3, which is 3. Now, so we know the answer to that's 3. But we also have a formula that we can use that says when you're adding 2 of the same bases, then all you have to do is multiply those numbers right there. Log base 4 of, what's 2 times 32? 64. And guess what? 4 to the 3rd power is 64. So that's how we get our 3. A lot easier than what we just did. talk about letter C. We'll come back to B in a minute. We're going to do C a long way first. This one. This is the understanding part I'm hoping you can get. That one says 3 to what power is 3? 1 plus 3 to what power is 27? So what's the answer to this thing? The answer is 4. But what if I condense and write 3 to log base 3 of, what's 3 times 27? 81. And 3 to the 4th power is 81. Now the one in the middle is not that easy, because I don't have a clue. 6 to what power equals 4? I don't know. I don't know how to rewrite them with the same base. I don't know. But I do know this. I do, huh? 4 and 9? Or excuse me, 4 and 6? But I do know that I can do this. Take your feet out of the chair. This is the same as log base 6 of what? 36. Oh, but I know what that is. That's 2. That's 2. So we are just condensing. We're going back to one single logarithm, okay? Do you remember how to expand? Now let's look at this. If I knew log base 6 of 36, I can break that up and I can say that's log base 6 of 4 plus log base 6 of 9. Because 4 times 9 is 36. I know these are equal. So how would I expand that log? Log base 2 of x plus the log base 2 of y. Good. Nothing else I can do there. What about B? Yeah, right? Somebody help me. They'll give you applause. There you go, there you go, there you go. Let's talk about C. Now I want you to look at C. Can we do 3 to a power to give us 18? No. Can we break 18 up into 2 factors of 18, like 2 and 9 or 3 and 6, where one of those at least could simplify with a log base 3? What did I hear? Could I do log base 3 of 9 plus log base 3 of 2? I could indeed. What's log base 3 of 9? 2 plus log base 3 of 2. Put your Chromebook away. Do you remember how to expand with division? You subtract. Do you remember this? That's right, because 10 minus 3 is 7. Same idea here. It's minus. This is going to be log base 2 of what? Of 32 divided by 4, which is 8. What's log base 2 of 8? 3. If you type that original problem into your calculator, you're going to get 3. What about B? Log base 7 of, where'd you get 7? 49 divided by 7, good, is 7. What's that equal? 1, good, 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 good. What about C? Log of, is it? Do that division on your calculator. You're going to get 10, 100,000. What are you going to get? 100. Oops. 100. So what is the log of 100? How'd you get 2? Because the base is 10. Good. The base is 10. Okay, you're doing fine. Are you remembering? Oh, yeah, we did this in Algebra 2. Oh, yeah, we did this in Algebra 2. Okay. You slept through Algebra. Why am I not surprised?
I wasn't trying.
Look at A on that bottom row. How can we expand that thing? That just went, what? With an addition. There you go. All right, all right, all right. So can we start it this way? Log base 2 of 2 plus log base 2 of m minus log base 2 of a. Good. Any simplifying? What's log base 2 of 2? 1. So this is 1 plus. Sydney, what you got? Cindy. Why did I call you Sydney? Lindsay, what you got? I don't know. Don't ask me. No. No. Let's look at B. Log base 7 of x Now I want to talk right here. Yes, you have a plus because the 49 was multiplied by y. Why would that negative have to distribute? Because this whole thing, you are dividing by that whole. Excuse me. Do you see that you're dividing by 49 and by y? So you got to have a minus there as well. Any simplifying we can do there? What's log base 7 of 49? 2. Good. So log base 7 of x minus 2 minus log base 7 of y. The next one's long. Can we just give it? No. But no, nothing. Okay. Let's go. What have we got? Log of, come on, somebody besides Maribel. Log of A plus log B plus log C. What now? Minus log D minus log D. Z, blah, 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 right there. Yeah. Nothing we can do about it. No, nothing we can simplify. Why didn't I just use E? Ask Miss Shulog if she typed these notes. I don't know. Good question.
Probably because the italicized.
Maybe. Maybe. Okay. I want you to type in your calculator that right there. just as it looks. And I'm going to get a drink of water. What are you getting? 8. How in the world is that equal to 8? Now, I want to show you another technique that you can use. When you have an exponent in a logarithm, we're going to pull that exponent down as a coefficient, and we're going to write it like this. Hey, you can't listen if your mouth's running. Log base 3 of 81 is 4. And what's 4 times 2? There's your 8. When you have a log and you have an exponent, you can pull that exponent down as a coefficient. All right, let's look at B. Based on what I just said, what can you do here on B? Move the 3 to the front as a coefficient, so this will be 3 log base 5 of 1/5. What is log base 5 of 1/5? Negative 1, good. And 3 times negative 1 is negative 3. Look at C. Now I want you to think about something. Remember, a log, what that says, just hush. That says 2 to what power is 32 to the 6th? Isn't that what it says? Can we work? Let's work on this way, because I can get 2 and 32 to have the same base. 32 is 2 to what power? 5. So this says 2 to what power equals 2 to the 5th raised to the 6th. That's 2 to the 30th power. So what's the answer to that? 30. What? 30. 30. Take that exponent, pull it down as a coefficient, and what are you going to write down? 6 log base 2 of 32. But what's log base 2 of 32? 5, and 6 times 5 is 30. See how much easier they are that way? Which? All right, fine. 8 to what power is 4 to the 15th? Can you get them to be the same base? So that's 2 to the 3rd power raised to the x equals 2 to the 2nd power raised to the 15th. X is 10, because 3x would have to equal 30. So we know x is 10. Let's talk about another way to do it. What could I do with that exponent of 15? Move it to the front, so I'd have 15 log base 8 of 4. Now we're thinking 8 to what power equals 4? 4. 1/2 is the square root of 8 equal to 4? No. Yeah, this is asking us 8 to what power is 4? That's going to be 2 to the 3rd power. It's not 3 over 2. Yeah, right numbers. 3x equals 2. X equals 2/3 times 15. And 15 times 2/3 is 10. I'm trying to show you different ways to do stuff, all right? Let's go to A down here. Simplify if possible. We're going to expand and simplify. All right, here we go. Log base 4 of 4. Keep going. Come on. Come on.
Yeah.
You bet. You bet. Now, when you simplify, you don't want to have exponents left. And anything that will simplify just to a number, you want to do so. Where do I have a 1? Log base 4 of 4 is 1. Plus log base 4 of x minus 9 log base 4 of y. Yep. You doing okay? What are you talking about? B. What about B? What are we going to do with B? Log base 8 of, which I could write as x to the 1/2. Keep going. Well, yeah, we'll get there in just a second. Yeah, we'll get there in just a second. And if you can do that in your head, I don't have a problem with it. That's fine. How are we going to rewrite this one? Minus. We're going to have to stop for just a minute because I got some people going to sleep. Okay, so we've had our little break. C. Can you do it all at once? All right, go. Besides Maribel. 3 log x plus 5 log y minus 4 log x minus 1. Let's talk about that. That's going to be log of z to the 0, right? What is anything to the 0 power? 1. So this really, now hang on. This really is just log of 1, isn't it? 10 to what power is 1? 10 to what power is 1? 0, absolutely. Absolutely. So that's just a flat old 0. There's your equation right there. All right. Now, I want to show you something else. A. You guys can do A in your head. What's the answer? 3. 3. Now, but I want to show you something. 125 is 5 to what power? What if I rewrote that as this? That's just 3, isn't it? See? Isn't 5 to the 3rd power 125? When you have a log and an exponential in the same expression, if the bases are the same, then what happens? It's just that. Now, would I have chosen to do that problem this way? Heck no, I just said 5 to the 3rd is 125. I wanted you to see that, though, so we can do this one.
Oh, 3x plus 1 is your answer?
Yeah. Now, why? Why is 3x plus 1 my answer?
Because the basis count.
Oh, because several different things. Because this is an exponent, right? And if I pulled that out in the front and said 3x plus 1 times log base 8 of 8, which is, this is 1, and 1 times anything is that thing. Good, Wayne. Now, you can also think about it. You can also think about it like this and say 8 to what power is 8 to the 3x plus 1? 3x plus 1. So see, if these bases are the same, they just cancel and you're left with 3x plus 1. What about C?
0.9.
That's it, 0.9. Now, I want to show you something. What if we had taken that exponent and written it as a coefficient? You're going to screw this up in calculus, so help me to goodness. What's the natural log of E? What's your base? E to what power is E? 1. All right. Solving exponential and logarithmic equations. This is a big deal for calculus. I want you to know how to do this, but you got it. Now, listen. We have already done problems like A and B and C and D and E, and so let's do. Okay. Look at A. No, 2 to the 4th is not 4. You could probably sit and just plug in numbers and guess and check until you got that, couldn't you? Could you? It'd be negative 1. Because negative 1 plus 3 is 2, and 2 squared is 4. So, but let's think about it this way. Can I rewrite 4 as having a base of 2? So then what has to be true? Well, 2x plus 3 has to equal 2. And you should be able to do that in your head. To 4, wait, 2, oh, what did I do that for? I was going, this is not right. That's better, isn't it? So x is negative 1. Yep, x is negative 1. What about B? Rewrite them both with what base? A base of 3. Good. So this is going to be 3 to the 3rd raised to the 2x, and we'll deal with that in a minute. This is going to be 3 squared to the x plus 2, and we'll deal with that in a minute. When I raise a power to a power, what do I do to the powers? So this is going to be 3 to the 6x equals 3 to the 2x plus 4. Good. So what do I know? 6x equals 2x plus 4. Can you do that in your head? Subtract 2x from both sides. 4x equals 4. X is 1. You can always plug your answer back in and make sure it works. C. What are we going to do to C? Write it with a base of 2. Good. 4 is 2 to the 2nd. Yeah. So it's 2 squared to the 3x equals 2 cubed to the x plus 1. So that gives us 2 to the, help us out, 6x equals 2 to the, can you do that in your head? 6x equals 3x plus 3.
3 plus 3 is 6, so it's 1.
Jaylee? All right, all right. What about D? What about D? What are we going to do to D? Two to the 4x equals 2 to the 5th to the x minus 1. So that's 2 to the 4x equals 2 to the what? 5x minus 5. Good. Can you do that in your head? I'm sorry, x equals what? 5? Yep. One more. We'll get you on this one. What do you mean I'm going to have a negative exponent? I always thought it was very odd that he kept just looking at the case of his calculator. All right. What about this one? What about E? Ah. Did you hear what Malin said? Can we rewrite that this way? Isn't 1/4 the same as 4 to the negative 1? You bet your boots. Can I rewrite this as 4 to a power? 4 to the what? You never heard you bet your boots?
No.
Where are you people from?
Texas.
No. Texas. What's X? X is negative 3. X is negative 3. Questions? All right. You are going to want desperately to use your calculator on this part, but I'm not going to let you. So just put it away. Let's look at this next set. I want to solve A, but I cannot rewrite 4 and 21 as having the same base. Well, snap. If I cannot do that, do you remember how your Algebra 2 teachers taught you how to get a variable out of an exponent? Take a log of both sides. Now, oh, quit it. Now, listen to me. Your Algebra 2 teacher did not teach you this, what I'm getting ready to. Your Algebra 2 teacher would have taught you, like on A, to do a log base 4, because the base is 4, right? I want you to do everything with natural log. Why do I want you to do everything with natural log? Because that's all we use in calculus. We do not use log in calculus ever. We use natural log. So I want you to do everything with natural log, which remember is just log base E, so it's not a big deal. Oh, but nothing. Okay, you can do this. All right, so let's just walk through it. You can do this. You can do this. So what I'm going to do to this one is I'm going to take the natural log of both sides. What can I do to that x? What's x? Well, x is the natural log of 21 divided by the natural log of 4, and that is all I want you to do right there. That's it.
Well, because you moved it across the equal sign. Yeah, it's not a log thing, it's moving across the equal sign.
I think I didn't even record that. Dang. I know, that is incredibly unfortunate. 3 cubed equals 2x plus 3. You do your magic and you get x equals 12. How can I be sure that's right?
Plug it in.
2 times 12 is 24 plus 3 is 3 cubed equal to 27. How? You have 2 more. Yep. These are the last 2 problems I'm going to teach you all semester. I don't know if I'm supposed to take that well or not. Okay.
It was an insult.
I figured it was an insult. No, I'm kidding. I understand.
For that several week-long break.
Look at C. What in the world are we going to do to C?
Well, did it go in the logs?
Say again? Why?
The logs are safe.
There you go. Because what we're going to do is we're going to condense those 2 logs because they have the same base. And you remember condensing when you have an add, you multiply. So this is going to be 2x times 5x plus 15. What in the world do we do there?
Cry.
Okay. Cry. Log of
10x. 10x squared
10x squared
plus 30x. So 10 to the 2.
10 squared equals, there you go, 10 squared.
So 100 equals all that. Yep. See, the more study's hard.
What are we going to do now?
So we get 0 equals.
Why do we have to get a 0?
You know.
You know what I'm factoring.
We're going to see if the sucker will factor,
Why is it minus?
because it's not.
Oh.
Thank you. Thank you.
Big guys that ain't.
All right, so what have we got? 10x squared? Aha! Minus 100 equals 0.
GCF too.
I heard, oh, you have a GCF. By gum. Ten times. Say again.
Almost right. Real close.
What's x? Oh. 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 If x is negative 5, then here I'll be taking the log of negative 10, and I can't do that.
So it's not an answer.
So, in this case, does 2 work?
Yes.
You sure?
Yes.
Here would be the log of 4, and here would be the log of
25. Some big number.
something positive, but 25?
I don't know.
How about 35?
I don't know. I'm paying a little extension. I just don't talk.
Yeah, and that's all that matters, isn't it?
No, it's 25.
Oh, I thought it was 4. Oh, I'm an idiot. It's fine.
What's
Sorry.
25?
Yeah, it's 25. I was thinking x equals 4.
Crap.
I was thinking it was x equals 4. I don't know where I got that. I don't
Man,
have
I
any
can
idea.
believe we're getting this right too.
All right. One more. No, challenge me when you know. You just think, oh, she's getting old and crazy. She just missed another one. Just think it. Don't say it to my face. It'll hurt my feelings. One more. Oh. And then there's Lily.
Oh, you know what?
What?
That's actually true. That's it.
Is
You
it?
actually look at it.
Can you?
Log is 10. 5 times 2 is 10. So you'll
Okay,
know it.
wait. I don't see something. Please.
I don't see either. Andrew, I don't see either. Log of
5x squared minus 5x.
I know, yeah, you're right, you're right. Are you okay with this piece? 10 squared. Yep. There you go. Well done. Minus 5x minus 100. Now Maylin's saying I got a GCF.
Yeah.
I can't keep up with you, Maylin.
It's on him.
Well, yeah, so let's check them.
I didn't understand what you were saying until the answer. I was like, wait. Because if you plug,
Can x equal -4?
no, because it would make one of them negative.
It would make one or both of them negative. Can x equal 5?
Yes.
Yes, because I'd be taking the log of positives.
You bet.
Are you insulting me?
No, imitation the highest smoke flatter.
There you go. Ladies and gentlemen, we are finished with semester 1.